Hey, welcome back to ATech Hub. I'm Techie. Okay, quick one for you today. What exactly is a database index? And more importantly, why is it this secret architectural ingredient that can make your queries like 1,000 times faster? I mean, if you've ever built an application, you know for sure that speed is absolutely everything. Users just won't wait around for data to load, right? But how do we actually achieve that instant data retrieval behind the scenes? Well, today we're going to break down the mechanics of database indexing. By the end of this explainer, you're going to have this crystal clear mental model of how this architecture of speed actually works in the real world. Let's dive in.
So, let's address the elephant in the room right off the bat. Why are your database queries painfully slow? It's a huge frustration, honestly, and almost every developer faces it at some point. You know that exact moment your code stops being this beautifully optimized machine and just starts feeling like it's trudging through molasses? Yeah, that one. See, when you first build an app, everything is lightning fast. You've got maybe 100 users, a few thousand rows of data, no big deal. But as your app grows and you start dealing with millions of records, those exact same queries suddenly start taking seconds, or worse, even minutes to execute. The core problem here is that as the sheer volume of your data increases, the fundamental way the database searches through that information becomes a massive, massive performance bottleneck. To really get this, let's step away from the code for a second. Think about a real-world parallel that perfectly illustrates both the problem and the solution. Imagine you're looking for one highly specific topic in a super dense 500-page textbook. But this book has absolutely no index. What do you have to do? You literally have to physically flip through every single page, scanning every paragraph until you finally stumble upon what you're looking for. It would be an agonizingly manual, painfully slow process. We're talking minutes, maybe even hours of your life gone. Now, picture that exact same book, but this time it has a beautifully organized index right in the back. All the topics are listed alphabetically, each tied to an exact page number. You look up your topic, see it's on page 342, and boom, you jump straight there. We are talking seconds, not minutes. It's a total game changer.
Okay, so how does this map over to our tech stack? Well, the absolutely crucial point here is that a database index works exactly like that book index. Literally, the exact same concept. Without an index, the database is essentially that poor person physically flipping through the 500-page book. When you ask it for information, it has to perform what's called a full table scan. It checks every single row in the entire database one by one to see if it matches what you're looking for. And at scale, yeah, this is exactly what causes those painfully slow load times. But when you add an index, the database acts just like the reader using the back of the book. It maintains a separate, perfectly sorted list of pointers. So when you make a request, it completely skips the scanning part and just jumps straight to the right rows, instantly.
Let's ground this with a concrete, real-world example. Say we are trying to find one specific user out of millions in our system. Step 1. You run your standard SQL query. Something like select star from users where email equals, and then the email address. This is where the magic actually happens. Instead of scanning millions of users, we hit Step 2. The database consults the index. Because that index keeps all those emails in a highly optimized, sorted list, it finds the match in a fraction of a millisecond. And finally, Step 3. The index provides the exact location, allowing the database to jump instantly to that specific user row. Just like that, it transforms a massive sluggish search operation into a highly targeted, instant retrieval.
Now, before we look at the structural costs, because let's be real, in architecture there are no perfect solutions, only trade-offs, we have to draw a hard line between reads and writes. I mean, you probably already know the difference between fetching a user profile, which is a read, and registering a brand new account, which is a write. But keeping these two operations completely distinct in your mind, that is the secret to knowing exactly when and where to actually deploy an index. It's not really about what they are, but how indexing structurally impacts them in wildly different ways.
So here are the fundamental trade-offs of database indexing. For reads, as we've seen, indexes are an absolute game changer. They give you those instant, 1,000 times faster speeds we've been talking about. But for writes, the story actually changes a bit. Whenever you add or update data, your database operations become slightly slower. You might be wondering why? Well, because the database doesn't just have to write the new row anymore. It also has to take the extra time to update the index to keep it perfectly sorted. And finally, we have to talk about storage. An index isn't just magic, it's an actual physical data structure. That means it takes up extra space on your hard drive. So basically, you are trading storage space and a tiny bit of write speed in exchange for absolutely massive gains in read performance. And that, in a nutshell, is the architecture of speed. You're basically building a highly optimized roadmap for your data. But it does leave us with a pretty fascinating question.
As our applications continue to scale to billions or even trillions of rows, will traditional B-tree indexes survive, or will AI-driven vector data retrieval take over entirely? Definitely something to think about. While you ponder that, I would absolutely love to hear from you all. What is your biggest database performance bottleneck right now? Let me know in the comments below. And hey, if you want a deep dive on exactly how these indexes are built under the hood, just comment the word index. Don't forget to follow and subscribe. We break down a new, complex engineering concept in every single explainer to keep you sharp. Until next time, I'm Techie, and thanks for exploring this with me on AI Tech Hub.